Good afternoon, student. Let me explain some questions based upon function. Yesterday we have learned what is a function, what is its domain, codomain and range of the function. And also we have seen the different type of function. The two main type of function that we have discussed, that is one-one function and onto function. Only these two definitions will be very frequently used in our question. Let us see the question. Let A be the set of all 30 students of your class and F be a function defined from A to n means set of natural number. Be a function defined as fx equal to roll number of the student x. Show that f is 1 but not 2. See the question again. A be a set of all 30 students of your class and n be the set of natural number. F is a function defined from A to n such that fx equal to roll number of the student x. Show that f is 1 but not 2. Now f is a function from a to n where fx equal to roll number of student x. As no two different students of your class can have the same roll number, different students have different roll number, so we can say function is 1 because the definition of 1 is what? It is when the different element from the domain has different images in codomain, then the function is said to be 1. So therefore we can write as no two different students of your class can have the same roll number or different students have different roll number, so we can say function is 1. Now here we have to check also it is onto or not. Now as there are 30 students, therefore roll numbers are up to 30 and 31, 32, 32 belonging to n are not the roll number of any student in the class. It means 30 numbers 31 onwards. They don't have any premise in A. Therefore function is not onto. Therefore the function is not onto. And moreover you can check our roll numbers are up to 30 and also the function is said to be onto when the range of the function is equal to codomain of the function. Now here the roll number is up to 30 but in the natural number set of natural number we are having the number up to infinity. So but here it means the range of the function is not equal to codomain, so we can say the function is not onto. Either you explain like this because these numbers they are not having their premise, therefore the function is not onto. And let us see another question. Show that a function from n to n given by f of 1 and equal to f of 2 equal to 1. It means image of 1 and image of 2 is equal to 1 and fx equal to x minus 1 for every x greater than 2 is onto but not 1. We have to show that the function is onto but it is not 1. Now here as f of 1 equal to f of 2 equal to 1, it means two different elements from this domain has the same image. It means two different element of the domain have the same image. So function is not 1. Let us check for its either the function is onto or not. Whenever you have to check the function onto, always we have to do, we have to take any arbitrary element from the codomain and then for that element we can prove that there is a x belonging to domain and its image is equal to y, then the function is said to be onto. I always we're having the same method to apply in the question. Whenever you have to check the function is onto, one method is what we have to prove that the range is equal to codomain, then the function is said to be onto. But in generally what we have to do in the questions to prove that it is onto, let y belonging to n from the codomain such that y is not equal to 1 because y equal to 1 is the image of what? 1 and 2. So let y belonging to, we have taken any arbitrary element from the codomain such that y equal to x minus 1. This implies x can be written as y plus 1. Now for every value of y, this element x equal to y plus 1 belongs to n. They belongs to n means here the n means the domain, and also the image of this element f of y plus 1. F of y plus 1 can be given as what? Putting this value here x minus 1, putting x equal to y plus 1, we are getting this is equal to y. Now we have taken any arbitrary element from the codomain, and for that value of y, we have proved that there is an x belonging to the domain and its image is equal to y. So we can say every element of the codomain has its preimage in domain. Therefore, we can say function is what? Therefore, the function is onto. In maximum question, we always adopt this method to prove either the function is onto or not. So therefore, we can say the function is onto. Let us see another question. Let f is a function from n to n such that fx equal to 2x is 1, 1 but not onto. Now here we have to prove that the function is what? 1, 1. So the other way you can prove in previous question, clearly it is given the different element they don't have, different element have the same image, the function is not 1, 1. Now here in this question, in maximum question, whenever you have to prove the function is 1, 1, already told you how can we prove the function is 1, 1. We can take two elements from the domain such that their images are equal. Let x1, x2 belonging to n means domain such that their images are equal. Putting the value of f of x1 and f of x2, it is what? 2x1 equal to 2x2. This implies x1 equal to x2. It means if the images are equal, then the elements are equal. Then the function is said to be 1. The first step we have done, the function is 1. Now we have to prove either the function is onto or not. The same method we will opt. Let y belonging to n from the codomain. Let y be any arbitrary element belonging to codomain such that y equal to 2x. Then x can be written in the terms of, then x can be written as, here y by 2. X must be here y by 2. And y by 2 does not belong to n. Y by 2 does not belong to n. Therefore, it does not have its any preimage in the domain. Therefore, the function is not onto because all the natural number are what? Whole number. Here, if x equal to y by 2, when I take y equal to 1, then x equal to 1 by 2, then this is does not belong to n. Therefore, y has not its preimage in the domain. Therefore, the function is not onto. Let us see another question. Again, the function is defined from a to b, defined by fx equal to x square, where a is having element 1 minus 3 and b is having element 1 and now 9. A is onto but it is not 1. Now here fx equal to x square. Clearly a has these elements and b has these elements. Now here f of 1 is 1. F of minus 3 is 9. F of 3 equal to 9. Now the range of the function is what? 1, 9. Therefore, range of the function is equal to codomain of the function. So clearly we can say f is what? Onto function. Similarly, now f of minus 3 and f of 3 equal to 9. It means two different elements from domain has the same image. So the two elements of A have same image. So function is not 1. See the question again. The function is given from A to B defined like this, where A is this and B is this. We have to prove that the function is onto but not 1. Now clearly fx equal to x square. When we are finding, because it is a finite set, easily only having 3 elements, easily we can find out its images. F of 1 is 1, f of minus 3 is 9, f of 3 equal to 9. So clear range of the function is what? Only element 1 and 9. Now the range of the function is equal to codomain of the function. So we can say function is onto. And also f of minus 3 and f of 3 equal to 9. It means two different elements from domain has the same image. So we can say function is not 1. This type of question can be asked in 1 marks question from this very unit. Now let us see another question. Check the injectivity. Injectivity means 1, 1 and subjectivity means onto of the function f from R to R. R to R means set of real numbers by fx equal to x. Either you have to prove this function is 1 1 or onto. Is it or not? 1 1 means injectivity, onto means subjectivity. Now here let us see here fx equal to x here. Let it take two elements from the set of real number as 2 minus 2 belongs to R, and but f of 2 and f of minus 2 is equal to 4 because 2 square is 4 and minus 2 square is equal to 4. Now the two different elements has the same image, so function is not 1 1. Similarly, you have to check its own. Now let me take any negative number from the codomain. I have taken any negative number. Minus 2 belonging to R means codomain. And now here x square equal to minus 2, x equal to plus minus under root minus 2. Now as minus 2 belongs to R and pre-image of minus 2 are what? Minus under root 2 and and pre-image of minus 2 are under root minus 2 and minus under root minus 2. These are two complex number, does not belong to R. So we can say the function, therefore we can say the function is not onto, and moreover whenever we consider any negative number from the set of real number that it does not have its pre-image in the domain, so we can say function is not onto. Now let's take another question. Let f is a function from R to R such that fx equal to modulus of x plus x is onto or not. Now here y equal to fx, this function is given equal to mod of x plus x. Already we have done in the 11th class what is a modulus function, how it can be defined. Mod of x equal to x if x is greater than equal to 0, equal to minus x if x is less than 0. We have done it in the linear inequality in the 11th class. Now here our function is mod of x equal to x. Now it can be written as y equal to x plus x equal to 2x if x is greater than equal to 0, because when x is greater than equal to 0, mod of x equal to x, then it becomes y equal to 2x if x is greater than equal to 0, and if x is less than 0, then mod of x is minus x. So it becomes minus x plus x equal to 0 if x is less than equal to 0. So we have defined our function in such a way by putting the value of the modulus of x. So our function becomes y equal to 2x if x is greater than equal to 0, and it is equal to 0 if x is less than equal to 0. Now here we have to check either the function is onto or not. Now here if x is greater than equal to 0, then y is equal to 2x. If x is less than 0, it is always equal to 0. Now the range is the set of all non-negative real numbers, because y always remains what? Either positive or it becomes 0. Now the range is the set of all negative real numbers, and codomain is what? Codomain is R. Now both are not equal, so clearly we can say function is not onto. It is a simple way to prove the function is onto or not. We can easily prove here in this question. We can find out the range of the function, that is the set of non-negative real number due to this equation 1. Whereas codomain is R. Both are not equal, so function is not onto. Now here let us see another question. The complete question that can be asked in 4 marks question also. Let f is a function from q to q, where q is set of rational number, such that fx equal to 3x plus 5 for all x belonging to q is bijective, where q is the set of rational number. Function bijective means we have to prove that the function is 1 1, and we have to prove that the function is onto function. In generally 4 marks of question, the question of this way can be asked in the board exam. Now the function is defined like this. We have to prove that the function is bijective. First we should prove that the function is 1 1. So what you have to do here, whenever you have to prove function is 1 1, let x1 and x2 belongings to q from the domain such that their images are equal. F of x1 equal to f of x2. Now putting these value here, 3x1 plus 5 equal to 3x2 plus 5. Simplifying, we are getting x1 equal to x2. So we can say function is 1, 1. As the images are equal, elements are also equal. So we can say the function is 1, 1 function. Similarly, we have to prove that second step, we have to prove that the function is onto. What method we can take? We can take any arbitrary element from the codomain, and for that we can prove that it must have its pre-image in domain and whose image is equal to y. Then you can say function is what? Onto function. Let y belongs to Q, codomain such that y equal to 3x plus 5. Then in the next step, always we have to express x in the terms of y. Now x equal to y minus 5 by 3. We take any value of y. This is always rational. It means this belongs to Q, the domain of the function. For every y belonging to Q, it is always rational number. And also image of this element fx equal to f of y minus 5 by 3. Putting this value here, in this we are getting here, this is equal to y. Now we have taken any arbitrary element from the codomain. For that we have proved that it is the image of some element from domain. So we can say every element in the codomain has its pre-image in the domain. So we can say function is onto function. Now as the function is 1, 1 and the function is onto also, therefore we can say the function is bijective function. Always whenever we have to prove the function is bijective, we have to prove the function is 1, 1, we have to prove the function is onto function. Let me take another example, and it is also one of the important question. The function is given like this: f from n to n defined by fn. You can take either x, you can take either n, because it's a natural number. So in the question it is written f of n equal to n plus 1 by 2 if n is odd, equal to n by 2 if n is even, for all n belonging to n. Check its injectivity as well as its surjectivity. It means we have to check either the function is 1, 1 or 1. Now here, let us check it for 1, 1. F of 1. F of 1, it is what? Odd number. So f of 1 is what? 1 plus 1 by 2 equal to 1. And f of 2, 2 is what? Even number. So therefore f of 2 is what? N by 2, 2 by 2 equal to 1. It means both these elements have the same image. Two different elements cannot have the same image. Therefore, the function is not 1. Therefore, function is not 1, 1. Let us check either it is onto or not. Now, let us see how to do it here and here. Now, let n belongs to capital N codomain. If I am taking n belonging to capital N codomain, it may be even, it may be odd. Now here we take both the cases. If n is odd, then 2n minus 1 is always odd. Is it clear? If n is odd, then 2n minus 1 is always 2n minus 1 is always odd belonging to n. And when I am taking its image, f of 2n minus 1, it is what? Odd. So by putting this value here, it is what? 2n minus 1 plus 1 on 2 equal to n. We have taken any arbitrary element and we have proved that it is the image of some element from the domain. So in the first case, it is what? Onto. Let us take second case, because the n may be odd, n may be even. If n is even number, then 2n is also even. If n is even, then 2n is also even. Such n, either the number is even or either the number is odd. That belongs to the domain. Now if n is even, then 2n belongs to n is also even, such that f of 2n even. So it is given by what? F of 2n is equal to 2n by 2 equal to n. Again we have proved that n is the image of some element from the domain. Now every element of the codomain has a pre-image in the domain, and therefore the function is said to be onto function. See the question again. The function is defined like this. For n is odd, then the value of the function is this. If n is even, the value of the function is this. We have to check either the function is 1, 1 or onto. Now clearly f of 1 we have find out. First we have taken the odd number, this is equal to 1. Then I have taken the even number, then it is equal to 1. Both these two elements have the same image, it is not possible. Therefore, the function is not 1. Now here we have to check forward either the function is onto or no. I have taken two cases. If n is odd, then 2n minus 1 is also odd. We have to choose this number such that it can be easily put and simplified. Now n is odd, then 2n minus 1 is also odd. And whenever finding the image of this number, 2n minus 1 plus 1 by 2 is equal to n. So therefore, if n is even, then 2n is also even and f of 2n equal to n. It means we have taken any arbitrary number and that we have proved that every element of the codomain has a pre-image in the domain. So we can say function is what? Onto function.